Now, let's look at the big topic here. We're getting comfortable with learning what sine and cosine. Sine and cosine. So, at this point, let me now introduce. You guys have seen this enough, but when we're on an x and y plane, right? The graphing plane right here, y-axis is the vertical one, the x-axis is the horizontal axis, right? Then let's say we pick any point. Right now I put that point in quadrant 1 or whatsoever, right? Not important, but any point in the way how we know it, this point has coordinates x, y. You guys all agree with me on that, right? Any point that we put on the plane has coordinates, the horizontal coordinates, the vertical coordinates, right? And so at this point, we'll go ahead and pay attention to this here. But so from where that point is, now we always want to, from that point, we always want to find. It's not a rule, but it's a good amount of time that we're interested in finding the distance from that point to the origin. The origin is famously known as 0, 0, right? So from any point on the plane, right, we can always measure the distance, the direct distance from the point to the origin right here. And that distance we call it, let's call it distance r right here, for kind of short for radius. See what I'm saying, huh? Okay. So again, r here, you can see that as a radius, but not too important about the name. It's basically a distance from any point to the origin. And then, so in that way, do you see an angle? See, an angle is how much opening up, right? From the standard position, the positive x-axis. See what I mean? Right? So any point makes an angle with a positive x-axis. So when we talked about angle, I didn't get too far into naming, but now at this point, let's start adopting that convention. Okay? So angle is a lot of time we use theta to name angle. That Greek symbol theta for angle. The way we pronounce that, theta. Okay. But so theta describes how much opening up, right? So that's the angle. And I should have written that in red ink. So that's nothing unusual. We have seen that before. Theta is the angle, right? So the name of that symbol is theta, right? That's r. Basically, right now, a couple times they call it radius, but mainly it's the distance from the point, right, to the origin. Sounds good, huh? Okay. And then, so the point now, officially, this point is referred to as, because now we're talking about the point and then how much angle it's made with the positive x-axis, right? And then for now, I'm concerning mostly, not always, but mostly I'm concerned about the positive opening up, right there, as you already knew. So you got distance, you got angle, okay? And so that point now we have a name. It's just a naming right here. We call it as a terminal point. So that point on a plane right there, if we reference that to the origin and then looking at that on behalf of it, how much angle it has made right there, so we call that point as a terminal point. That's even a better reason why we call that terminal point, and you guys will get to that. Right? But more importantly, what I want you to emphasize here is any point makes an angle with the positive x-axis, either in a positive direction or in a negative rotation with that. Okay, and then it makes a distance. But so now, see, this is where you bring back your previous learning right here, just right here at this point, not too long ago. It's distance. So how do we calculate distance? Isn't it x minus 0, because one of the point is x, right? X minus 0 squared plus y minus 0 all squared, right? We take the square root, and that equals the distance r. Because I was saying that r is the distance, right, from that point to the origin, right? And we've seen that not too long ago. And so that means this equation right here is reduced down and ridiculous. We don't have to write x minus 0 all squared like that, right? It's reduced down to, how about in the square root? We got x squared plus y squared, and that equals r. See what I'm saying now? Okay. So ladies and gentlemen, nail this down right here. This is one famous formula that you're going to carry for yourself for the rest of your mathematical career right there. I'm talking about the special distance from any point to the origin, from any point to the origin, right, on the plane right there. We always have that famous formula, r equals the square root of x squared plus y squared, right? And that tells you how much radius, how much distance your point stands away from the origin. See what I'm saying, huh? Right? My Calc 1 students use that a lot. My Calc 2 students use that a lot, and all of my calculus students, right? Even they go further, as long as you're calculating how much distance from the point, right, to the origin. That's the formula. Okay. And then famously, people from this point on, you will keep hearing more people refer to that as r, the radius, but more, especially that radius from the point to the origin. Sounds good. Okay, but now there's more. So this is one important formula, right? Don't forget that. But then here's we're doing math, right? So we got to be able to go from one formula and be able to derive into another important formula. So here's the thing: from your from your algebra experience here, from the current formula, y is x squared plus y squared in the square root, right, equals r. See, from your algebra learning, you have you can square, you have your legal right. I was about to say that. You got your mathematical legal right to square both sides of an equality. And you see the work that I did with them, starting with that same old equation we just now seen, right? I square both sides of the same equation. So it's not anything that you're surprised with, right? You can always square both sides of your equation. But then let's look at the consequence of doing that. So r squared on the right-hand side becomes r squared, nothing much about it, right? But the square on the left-hand side here will cancel out the square root, right? Making your left-hand side to become like this, a much cleaner version, just x squared plus y squared equals r squared. See what I'm saying now? Okay. So far that's just the algebra. So wait a minute, what do we notice out of this? Something special about this. Let me demonstrate. The picture is right here as well, but let me make a clean version of the picture. X and y is that terminal point, right? And then we already knew that it made some distance, r, we call it the radius. Radius. Okay? This is r from the origin. Okay, 0, 0. Y, this is x right here. So in this way right here, what equation here do you recognize? Circle. It's a circle. What's special about that circle? What's that? Center at where? 0, 0. 0, 0 is the center, right? What else is special about that circle?
Endpoint.
What's that?
Diameter.
It takes that right? It takes that direct distance from the point to the origin as the radius. See what I'm saying? No? So my point now is that, hey, any point on the plane now, you can purposely think of that there's always a circle around the origin that contains that point. See what I'm saying? No? Any point sitting on the plane, right, in these days, there is a circle center at 0, 0, right, and it contains that point, and it has radius r, and we already learned how to calculate that r there. You guys see what I mean? Right? So, see, you have reached some fluency with that, and now we think of that as an impact there, right? And I never said that the radius has to be 2, the radius has to be 1, I never said so, right? The radius can be just whatever that comes out from the calculation. So just like that, that's why, see, there's always an angle theta, right? Indicating how much opening up, the positive x-axis, and that's why this point on the circle, we call it as a terminal point. Because now you know that your point has to be on some circle, right, at some radius, away from the origin. Then that point on the circle itself is called a terminal point, just like that, how we defined that terminal earlier. Okay? And then how much angle that's opening up, right? That's the angle theta. Write it down, what I said earlier as a remark there. So from what we've noticed, right, as a remark, any point at x comma y right here, right, is on some lowercase distance r. That's what we understand about it just in the picture earlier. Show some quick demonstration. Just think about it like this. You got, this is not even a formal example right there. You guys would like to pick a point for me? Pick a pair of numbers there, and we call it as a point. Pick one pair of numbers. Anything.
1, 3,
1, 3. There you go. So 1 for x, right? The first number is always x. You already know, right? So 1, 3 is about here, and I may be off scale a little bit. See what I mean? So that's x, that's y, right? So that point definitely will make some distance from the origins. 0, 0. You want to say no? So let's find out what that radius is. Right? So that radius, the formula was given right there on the board, right? So the radius. And now I really mean the radius is how much distance from that point, right, to the origin. So the radius here is r equals, right? Now we go as far as the calculation, it goes with 1 r squared plus 3 r squared. Right? It's the square root of x value, I mean x squared plus y squared, right? And you see I use parentheses very closely right here to indicate that the pair of values you guys give me could have also sometimes be negative, right? So use parentheses to make sure we include the negative sign, right, before we take the square. You guys follow it? So with this right here, hey, what's 1 squared plus 3 squared? 1 squared is a 1, right? 3 squared is a 9, so we're looking at the square root of 10, right? There's no, there's no problem at all to write your final answer as the square root of 10 in exact expression. That's good. But so that means further. I hope I'm not going too fast. But so we calculated, you have calculated, would be how much distance that point is, right? That point is made from the origin right here. And so from that means as an impact, this point 1, 3 is on the circle. There's that circle. So now you can say, hey, 1, 3, right, is on the circle. On the circle, what the circle center is 0, 0, right? Center at 0, 0. That's what we always want, right? But then, what's the radius here? Radius square root of 10. See what I mean? You know we're on that circle. And then the equation for that circle, this is optional for you. And this is not even a formal example. I just wanted to lead you guys through that activity so you get comfortable with that idea again, right? But so that's the equation for this circle here. You're fluenting up, right? Center at 0, 0. So it's x squared plus y squared, right? And that equals what? We squared the radius here as well, equals 10. See? That's the equation of the circle. And I didn't say that the radius is going to be 1. That radius here obviously was the square root of 10, right? Far larger than 1. See what I mean? Okay, so now we're going to let's specialize. So there are so many circles, as you have already learned. If you take this, the origin is at 0 over here, there's a circle, the center at 0, 0 with radius 1/2, for example, right? And then there could be a circle center at 0, 0 with radius 4, for example, right? See what I mean? There are so many circles taking the center at 0. So we want to especially focus to one circle first. So let's build our understanding from one special circle. We call it as a unit circle. And I mentioned this term before, right? It's that thing you guys are using with that. The unit circle, center at 0, 0. Okay. But then got radius. You guys recall what I mentioned before about the unit circle? How big is the radius? It's 1, right? The radius is just the distance right here, so it's 1. And so the unit circle as a reminder, because we've seen a little bit of that. Here we set forward into using it. X squared plus y squared, right? Because the center at 0, 0. But then that equals what? Equals 1 squared, right? Which is 1. Equation of the unit circle. All right. Now it's not like anything super exciting about to learn about a unit circle, and I actually also mentioned it briefly in some of the earlier lectures, right? So it's not the intention to introduce you guys to the unit circle. This is about what we're going to be doing with the unit circle over here. So now, this is a unit circle. So any point on that circle has an x and y coordinates, right? We call it as a terminal point. Again, just that language earlier we picked up. Okay, so now from that point it makes that radius, right? And the radius now is for sure is always 1. Because for now, it's the rule, the special rule with that unit circle, right? It's always going to have to maintain a radius 1, and this is 1. And I'm not even going to be too concerned about what exactly. I just know that that terminal point will have carry out. We must be carry some to the values x and y, right? And then because it's the terminal point, and then the angle theta is here, okay, at the center, indicating how much opening up. But just special, a little bit special that the radius there is 1. Okay. So now here's what we define. So from that terminal point, right, the angle is indicating how much opening up from the x-axis, positive x-axis. There's the x-coordinates refer to the x-coordinates on that terminal point refer to how much distance here. You guys agree? Okay. And then the y-coordinates refer to how much distance here. This is the y value. You guys follow with me on that, okay? It's like things we're seeing back in the algebra days, right? The y-coordinates is the vertical coordinates. That's why I put curly braces, right, to indicate that here. And then this x-coordinates drop directly down from that point down here and how much distance it's made for here. Right? That's the x-coordinate. Sound good? Okay. Now, ladies and gentlemen, you guys are getting right there at that new definition here. So, this is now called a definition. This definition for now, it's my style. I'm introducing for you guys based on the unit circle. Okay? On the unit circle. So you got to be on the unit circle first for this definition. So when you're on the unit circle, then the angle, whatever angle that is, right? Whatever angle theta that is, we define. Or whatever angle theta that is. You guys, I want you guys to pay attention to this. We define the sine of theta, right? Sine of the theta means the y value. Okay. So when you're reading an angle theta right there, right? The sine value is the y coordinates, right, of your angle of the terminal point on the circle. That's the y value. Okay, that's sine theta. Okay, so notationally we write sin, right? And then in parentheses theta. We're talking about it's a value reference to that angle right there. Okay? And that value means the y value. Okay? So that's we define. We let it be that way. So sine value of the angle theta is the y coordinates, the vertical coordinates. And then just like that, we define. So there's not too much anything to question. It's just, that's the way we let it be like that, right? That's why it's a definition. We're going to start taking that definition. And so in that way, from that angle theta again, because agree with me already that any point, right, make some angle theta with the positive x-axis. And I'm not talking about I'm not saying it doesn't always have to be positive angle, but any angle with the x-axis from the terminal point, we can now define a value that's called a cosine value. Right? The cosine COS, okay? I call it cosine, but notationally we write COS. Right? So cosine of that angle theta refers to the x value, the x coordinates of the terminal point. Right? See, so let's just do. So when you see this symbol over here, the way you read, right? This is how you read. Sine, and then this is how we write that conventionally right here. Sine, S-I-N-E, like that. Sine of angle theta. It refers to a value, right? And that value means the vertical coordinates on the vertical coordinates of the terminal point on the unit circle. Okay. That's the way how we read it. And then cosine, similar. Notationally, we write only COS. Attached to that angle, but it means when you're saying it or verbalizing it, it's cosine of theta. When you're reading it. Okay, so now really let's call it example 1. But this example 1 here, let me tell you, oh boy, it's going to be a big one. We're going to take our time exploring this, right? So, and then through this example, we're going to build our skill over here. Build our understanding. So let's call it example 1. So This example one, the instruction is simple. We just want to evaluate. Right? So for a good majority of times, theta is the symbol that indicates it's an angle. Right? I'm going to lead you guys through different problems here so that you can click with the understanding. So let's look at sine of 0. Okay? Doesn't matter. It could be radians, it could be degrees or 0 degrees or 0 radians, right? 0 pi. That's what I meant, right? But what is the value for sine of 0? So 0 is the angle. You already knew it, right? But we want to find sine of 0. So now from the explanation I've given earlier, on the unit circle, assuming your unit circle is here, right? Then where's the angle 0? That's why I got you guys into doing that, filling in your circle with the angle, because the angle 0 is this angle, am I correct? You guys all agree? It was right in your activity just earlier you did, right? So this is angle 0, 0 pi, because you didn't rotate at all, right? What's the terminal point here?
Oh, 1, 0.
Okay, 1, 0, right? 1 for x, okay, and 0 for y. You guys following? Okay? And so now from that definition we had earlier, sine of the angle, right now the angle is 0, but sine is the we understood sine as the y value, right? For this current angle 0, right? 0 opening, but the y value, how big is the y value in this case? It's 0, right? Yes, ladies and gentlemen, from now on, yes, sine of 0 equals 0. But that 0 that we came out right here, right? It's the y value of the terminal point correspondingly. You guys read that? Okay? And yes, you can call it problem part A, right? And so just like that, still in part A, why don't you think about cosine of the same angle? So same angle is 0. What's cosine? Where's your terminal point on this unit circle? Radius 1, right? The point is still here, see what I'm saying now? And you guys already gave me the coordinates of the terminal point right there. Right? So what's the cosine value for this angle? This is angle, right? This is angle. What you're looking for here, we're not looking for the angle, we're looking for what's the what? The x value. There you go. The x value, right, on your. There you go. See how it comes so natural for you guys now? So cosine or sine, we're talking about the horizontal coordinates, right, and the vertical coordinates. That's what it is. And the thing that's trapped inside of your sine or cosine operations, right? These are the angles. Yeah. So we already knew where to locate the angle. So just locate that angle, find out where the terminal point is, right? And then you're gonna simply read out the x and y coordinates. Okay. But right now we're doing this on the unit circle, right? And then later on I will show you guys how we're gonna move out from we break away from the unit circle and move on to the other circle. Does it necessarily have to be units radius 1 anymore? See what I mean? I think I still have some space, so I'll part B, make some easy ones. How's that? How about sine of I'm gonna make that call, okay? Pi over 2 over here. You guys remember where pi over 2 is? That's why we have that activity with that. And it's not a test, right? You guys just build your skills, so feel free to use that circle. You guys spent some time filling it out like that. Okay? And then let me do this as well. Alternatively, people write sine of 90 degrees, right? I'm just writing the angles in two different ways right here. Sometimes you see sine of pi over 2, and sometimes sine of pi over, sometimes theta is 90 degrees, right? Sometimes theta is given as radians pi over 2. Right? So that's what I meant. Theta equals pi over 2, and theta equals 90. Right? So where is that? Like I said, the routine here is to locate that angle, right, on your unit circle right there. So how big or where is your, and this is positive, right? I hope you guys get forward with that. So positive means from the positive x-axis, we will go a positive rotation, right? And hits 90 degrees, or we call it the pi over 2 angle, right? Where is that at? Right here, am I correct? This is the opening up, right? But where's the terminal point? Right there. Okay? So ladies and gentlemen, read it out for me. What's the coordinates? What are the coordinates for this terminal point? 0, 1, there you go. It switched to a different point, right? right? So that point right there, that terminal point, right? The opening up is a pi over 2 rotation, or the opening up is 90 degrees opening up. That's the opening up, the angle. So we already knew the angle, but we located that terminal point again at 0, 1. Sounds good then? So now can you go ahead and answer this? What's sine of pi over 2? Or sine of 90 degrees? Same way of reading it. Sine is the y value. 1. Yeah, right? Or sine of 90 degrees? 1. See what I mean? That same way. Cosine, yes, you can call that pi over 2, right? Or cosine of 90 degrees. Two different ways of running it. Cosine is the x value on the unit circle. Cosine is the x value of the terminal point on the unit circle. So what is that x value? It is 0, right? It's right here, 0. Yes. See that? Okay, very good. Now, the angle here about a, guys, when you open up 180 degrees, what angle is this? I call it 180 degrees. How do you write it? Radians. Like that. It's pi, right? So, what's sine of 180 or sine of pi? Where's your terminal points? Right here, right? That rotation again, right? Leads you right to this terminal point. Go ahead and read the terminal points out for me first. Read the coordinates of the terminal points.
G, -1.
-1 for x, that's right. Comma.
0.
There you go. You guys all agree? Now, what do you say? Sine of 180, or also known as sine of pi, right? What's the y value coming out right here?
0.
Big old 0, right? Both these come to 0. I mean, it's not very usual that I'm writing it that way, but please forgive me. Both turns out to be the same answer. All right, so same way right there. We got at the same at that angle, right? How about cosine of 180 or cosine of pi? Two different ways how you see that. Okay. What's the cosine value for this angle? 180 or pi is just different ways of writing the angle, right? I like that. -1. The x value, right? 1. Either way, we're going to let you reach that answer. Good. -1. And then, what about when the angle is 270 degrees? Let's find sine of 270 degrees, or alternatively, what do we call what's the radians for 270 degrees?
3
Pi over 2. There you go. See? Just a couple of days right after we learn that, you guys need to flip your notes and read that, right? Trust me, by the next couple of weeks, okay, you're going to read this fluently. That's just a skill that we keep building up. Right? Okay, so that's the angle, but now we're looking for the sine value, right? So the rotation in the opening up, the rotation goes in the positive direction and heads down to 270 degrees. Okay? You guys all agree where I like that angle? Right? And that's a pi over 2, so where's the terminal point? Right here, right? So all you have to do is read the coordinates of the terminal points. Liam, what do you have? Okay.
That one?
Yeah? The terminal, I mean the coordinates.
Oh, the coordinates.
Think over one more time. X value, Y value.
0, -1.
There you go.
Right.
All right. So in this way, what's your answer for sine? Remember, sine. Right now it's very new, so it takes some time to process, but that process will become very quick as you get better fluent at that. Okay, so what's sine of 270? The y value of 270. -1. There you go. -1. Right? Or the way how you write into an angle. Right? Pi over 2 or 270 degrees. That sine value comes out being -1. It's the y value on the unit circle. Right? It's y value on the unit circle. So just like that, at the same angle. Anyone would like to volunteer for me the cosine value? Either way, how you write your angle. Sounds good. In part D, I want to call that. How about the angle here is, let's call it sine of 45 degrees right there. Or you can also write it as a sine of, what's the angle ingredient for pi of, for 45 degrees? Yeah? Pi over 4. I agree. A positive rotation, right? I agree. But we want to look for the sine value. See what I mean? Okay. So allow me to only write down one equal sign right here. But this is how we're working it out. So remember, sine or cosine refers to the vertical coordinates or the horizontal coordinates, right? Sine is the vertical coordinates of the terminal point. Okay? Cosine is the horizontal coordinates of the terminal point again. The x value and the y value. So, in order to find that this time, let's go ahead and draw the picture. You've got to draw the picture right here. There's your unit circle, and right now we just stay on the unit circle for now. Before we actually move out to the bigger circle, right? But how do you locate that terminal point when it's 45 degrees rotation? Isn't it this one right here? Radius 1, 45 degrees or pi over 4, that's right. Pi over 4. We just got it right kind of down below over here, but that's how big the angle is. So I need pi over 4. Okay. Then, what do we know about this special angle? Now, when it's exactly 45 degrees or a pi over 4 ingredients, what's special about when you draw that? What do you notice? Terminal point is here, yes. X, y, right? This distance here is y. This distance here is x. Okay, the pi over 4 is how much opening up in radians, right? But what's special in this triangle? Your eyes are telling you. What's that? Is it? Yes. I mean, it's always going to follow a right angle. When you have an angle like that, right? And you drop the distance here, we always want a right angle. But even I want you guys to recognize even more, some better specialty about that. Yes.
45, 45, 90.
Yes, it's a 45, 45, 90. But what even further special about the 45, 45, 90 triangle? And we know that this is radius 1 for them. You see, my drawing right here is off scale all over, but you can kind of recognize it. What's special about these two distances? Yeah?
Are all sides equal?
They are equal. The x and the y on the 45, 90s, right? The x and the y, the two, see the adjacent, right? And the opposites, they are equal. See what I'm saying? No? Okay? So we're gonna take advantage on that understanding. We're gonna take advantage on that from that understanding that you guys had, right? So in that case, again, from 45 degrees, right? X and y are equal. Okay? And you guys mentioned that to my ear, right? So this is what we do right here. Well, we know from Pythagorean theorem, or in the way we just introduced earlier, x squared plus y squared, right, has to equals 1. You guys follow it? Because we're on a unit circle, right? So no matter where we're at, the x squared plus y squared has to equal 1. And we're on this special unit circle. Agreed? Okay, but now I'm going to bring in that information right here. X equals y. Meaning you can make your choice here, but I'm gonna let that y equals x again. You guys following? Because x equals y or y equals x. That's the other way of saying it, right? So that means your equation here will become x squared plus another x squared, right? Equals 1. So we have that equation simply because our point is on the circle radius 1, center at 0, 0. But now further we knew that x equals y, right? So I substituted x into y. That's why I produce x squared plus x squared again. So that equation here is even further making it 2x squared, right, equals 1. Okay. Can you go from there to find out what's the x value for me? Now also, you see, quadratic equation that we can solve for, right? Yes, you can divide both sides by 2, right? Making it what? X squared equals 1/2, right? And then at this point, you can take the square root of both sides. See what I'm saying there? And then you're looking at x equals. Now, it's always, anytime you're taking the square root, both sides you go with plus and minus, right? So it's plus and minus square root of 1/2. Agreed? But here's the thing. We have to make one choice only. Now, our x value right now, is it a positive x value or a negative x value in the way how our point looks? It should be a positive, right? Because in the position where I put my terminal point right now, right? The x value must be a positive one instead of negative. You know what I'm saying? Now, the result here only says that, hey, in order for x squared equals 1/2, x can come out with 2 different values, but then in this particular situation, we got to choose a positive one because the x value is positive, right? Are you seeing that right from the picture right there? So now, that means we have made our decision. So x equals square root of 1 over 2. We're close. Yes. But I'm only saying we're close. You can write it down. That's your answer. Sine of 45 degrees or sine of pi over 4 is a square root of 1 over 2. Good? But here's the thing. The rest of the world is not writing it this way. I'm just saying I'm trying to make you guys join with that big family of the rest of the world doing trigonometry up there. The rest of the world is not writing it this way, even though it's already the correct answer. The way how the world is writing it, well, it's a 1 over square root 2, right? As for square root, you can tear it apart into top and bottom. You guys agree? Right? So that's right there. But people in the rest of the world don't like having an irreducible square root in the denominator like that. So we're going to purposely multiply a square root 2 and multiply a square root 2 to top and bottom. Right? So from the same answer, but we're doing this. We break that down into 2 separate parts, and we multiply with square root 2, top and bottom. We're rewriting it as a square root 2 over 2. Right? This is the famous sine value for the pi over 4 answer. Okay? And all of these algebra techniques that you guys seeing right now, you should have learned that back in your any of the courses before this, right? Okay. But the whole work, I'm doing it. I made a flaw right here. The x value is the cosine, but really the reason I wrote this simply because x equals y. See what I mean? Okay. I solved the triangle, right? But I came out with x value. It's just my style. I tend to like to say with x, okay? But x is not exactly the answer here. The y value, but in our particular case here, x equals y. See what I mean? X equals y. That's why sine value still come out square root 2 over 2. And all that explanation of mine about the algebra work stays exactly the same. X equals y. So guess what? There's no need to reinvent the wheel right there. You already have all that work. Cosine, you can also write this down like that. Cosine of 45 degrees, right? Or you can also say that as cosine of the pi over 4 angle, right? That is all of that. It's also a what? Square root 2 over 2. Because that point right there, now you label it square root 2 over 2, right? Comma square root 2 over 2. And x equals y. Whoever said that earlier for me. See what I mean? Right? let's look at another problem here. So we're continuing with example 1 with that. So part E right here. Let's just look at how about sine of the 30 degrees angle, or in radians you can call that it's a, guys, in radians what's the radian reading for the 30 degrees angle?
5/6.
It's a 5/6. Yes, within one rotation. 5/6. Very good. Okay. So let's draw out a picture again. So 30 degrees, right, or 5/6. But we were looking for the sine value. So in our explanation earlier, sine value on a unit circle, it's defined to be the y value, right, of the y coordinates of the terminal point. So your unit circle is here. This time, now I'm trying my best to get that 30 degrees angle with that. But of course, forgive me if I'm off scale or anything like that. Right? So here's the 30 degrees angle, or the same as the 5/6. Right? So that's the 5/6 angle and the 30 degrees angle right there. So your terminal point right there, right? It has always an x coordinate and y coordinate. So the y coordinate is this vertical distance that drops from the terminal point down to the x-axis, right? And then the x coordinate is that horizontal distance comes from the origin out to that foot of the vertical drop again. Right. But this distance right here, that's what we call it x, right? And this one right here is y. So I just realized I had to label my 5/6 a little too awkward with that. So 30 degrees angle or 5/6. That's how I'm seeing it. Okay. And so, in order to, so this is what sine value. This is the vertical distance we want to calculate again. So again, from the explanation, from the definition we given out earlier, that sine value on the unit circle, sine value is the y coordinates, right, of your terminal point. So your terminal point lands right there on your unit circle. And keep in mind, this radius is 1. Sounds good? Okay. And so now I'm gonna extract out that particular triangle. Just think right at that triangle over here. I mean, right here, of course, we have a right angle, right? Needless to say about that. So there's a right angle, and then your angle right here is going up is about 30 degrees angle, right? Or 5/6. Two different ways of seeing that. So we want to look for this right here. The hypotenuse in this way right here of our triangle, the radius of the circle is acting as the hypotenuse of your triangle. You guys familiar with that term right there? Right? And then the right angle is right here. So now what's special about this triangle? This triangle is a little special. It's a 5/6 angle right there, or 30 degrees angle. Okay. So anyone recall some specialty about this triangle from your geometry course? I mean, in a way how it looks right now, maybe let me just remind you, in a way how it looks right now, there's going to be one side being longer than the other side, right? And then of course, in any right triangle, the hypotenuse is the longest side, right? But then aside from that longest side, there's always one leg being longer than the other leg. Okay. But then there's still something special. You see, in a way how any right triangle, I mean, in a way, this is commonly in geometry we refer to that as a 30, 60, and 90 triangle right there. 30 to 60, because that angle right here has to be 60, right? Because the sum up, it has to be all 180s. So 30 is here, 90 is there, and it's got to be 60 is here, right? And so the 30, 60, 90 triangle right there, then this shorter leg right here is always rule of thumb that it's half of the radius. I mean, it's half of the hypotenuse. It's always like that. Okay, that's just one understand. So the hypotenuse here is h, right? And it's a 30, 60, 90 triangle. And right here, it's going to always be the shorter leg right here. It's always going to be half of the hypotenuse. And then whatever that comes out from the Pythagorean theorem. So now we're going to use that. We're going to utilize this understanding right here. And we will bring that into our particular situation. So the hypotenuse is known to be 1 because we took this picture right out from the unit circle, right? And so this length right here now has to be what? 0.5, right? Or let me mention it clearly. How about let's stay more with the fraction then. So about 1/2 then. You guys with me? Yes, we got 1/2 of that, right? Yeah. And then since we're still working at this picture right here, then let's also calculate this unknown length for now. Let's call it length x. Yeah. Pythagorean theorem says hypotenuse squared, which is 1 squared, it must equal x squared plus 1/2 r squared. You guys with me there? Right. And 1/2 r squared is a what? Is a 1/4, right? And then 1 squared here is a 1. So this same equation here turns out to be 1 equals x squared plus a 1/4. Are you following my explanation so far? And so in that way, here's how I'm seeing it. We can subtract the 1/4 because the idea is we want to find out how big that length x is, right? So I'm going to subtract 1/4 from both sides and leaving it. I'm going to make that, see, 1/4, I mean 1 subtract 1/4, giving me a 3/4. That equals x squared. Anyone question me of how I got this? I subtracted 1/4 from both sides, right? Subtract 1/4. Subtract 1/4 from both sides, and that leads me to 1 minus 1/4 is 3/4, right? So 1/4 got cancelled away, that's why I got x squared. Okay. So the 3/4 equals x squared. Then how do we find out the x values? So that means what? X squared, I mean x can be found by taking the square root of both sides, right? But definitely we got to go plus and minus square root of 3/4. But square root of 3/4 is the same, and so you can further write plus and minus square root of, and it's a square root of 3 over square root of 4, but square root of 4 is a 2, right? Am I going too fast for anybody? Okay. So now square root of 3/4 is the same as square root of 3 over 2. Okay. All right. So I'm holding on to these values again. So back to the question that we've had right now, have we found our sine of the sine value for the 30 degrees angle or sine of the pi over 6 angle? What is sine of the pi over 6 angle for you? Sine of 30 degrees, right? Or sine of the pi over 6 angle. What's the answer here?
Does it have?
It is half, yes. It's the y coordinates of your terminal point, right? We found that even before we got to this. Yes. That's a positive 1/2 in the picture. Okay. Both of those two different expressions, right, come out with the same answer again. So now in the meanwhile, I mean at this same angle right here, at this same angle, what if I was asking for, hey, what about cosine of the 30 degrees angle? Right? Cosine of the 30 degrees angle or cosine of the pi over 6 angle, different ways of writing it. Right? What is your answer? Think about what can it be for the answer. Cosine is the x coordinates, right? What do you see?
Is it positive?
It's about positive, right?
Square root of 3 over 2.
That's right. You see, my work here, I decided to leave it kind of hanging, right? Technically, we got 2 answers after we solved that equation, right? We got 2 answers. Now, particularly in this situation right here, our x value is going to be a positive one. See what I'm saying? Right here in the picture, the x value lands right on the first quadrant, right? Or it stays on the positive side of the x-axis. That's why between the 2 answers, the plus and minus, we chose a positive one. Sounds good? And that's now we call it as the cosine value for the 30 degrees angle. Okay, so cosine of an angle is the x coordinates of your terminal point. Okay, so now you can write as a positive 3 over 2. Okay, so that's the answer. 2 different ways of how you're writing it, right? Either the cosine of 30 degrees or the cosine of pi over 6. That runs into a positive square root of 3 over 2. Right? You see that's the exact same white unit circle that I was handing out. Okay. So the zero angle is here. Sounds good? Right. So the zero angle is there. We found that the sine value was, so right here I have to write that as a whole pair of values, right? The sine value, which is the y value, we found it 0. But the x value, which is the cosine value, was a 1. That's why I'm writing it. See what I'm saying now? And then up there, that was a pi over 2 angle, right? And of course, the pi over 2, the radians is new convention. That's why I keep using that, so that you guys get more fluent in that, even though you can also understand that as a 90 degrees angle. Sounds good? And we've done that probably earlier, like part of the example. The cosine for that, x value is 0, right? But the sine value is 1. We found that from earlier part. This is an example, right? And then so on and so on. This is the pi angle right there. Opening up, pi angle. And we came to negative 1 for x, right? And 0 for y, which is the cosine is negative 1, right? And sine is 0. And we came down to this one right here. Right? That was the 2D pi over 2 angle, right? The rotation goes positive this time for now. Okay? And then the coordinates for that was, for that point right here, was 0 for x, negative 1 for y, right? And then we go to, when we complete the circle, it's a 2 pi angle. So 2 pi angle is the same as coterminal with the 0 angle, right? Remember coterminal, right? The 2 pi angle is also coterminal. That's what we call it. It's a terminal point, right? Coterminal with 0 angle. So it turns out cosine of a 2 pi is also a 1, and then sine of a 2 pi is also a 0. See what I mean? Right? And then further, we work on this. See, right here is the angle pi over 4, right? You guys read that? Right. And then, so from earlier work, in this short example, we found what the sine value for that was a positive square root 2 over 2. Remember that work that we were doing from yesterday? I wish it wouldn't have pencil with me, but this vertical y distance, right? That was the square root 2 over 2. We did that calculation earlier. And then so the same way over here. That's square root 2 over 2. And this line here that stops right there, right? The line from here to here is also a square root 2 over 2. See how we develop that idea so far? Okay. Any question for me? And then just now we finished right here at that angle, right? It was a 30 degrees angle. Or we call that as a pi over 6 angle. Sounds good. And what did we find? Okay. So we found out that the sine value, see, this vertical distance right here, that's the sine value, right? So the sine value we found out, we calculated it was 1/2, and we utilized directly the property of our unit circle and being, the property of being a 30, 60, 90 triangle. And then the longer leg right here came out being a square root 3 over 2, right, according to the Pythagorean theorem. Sounds good? Right. So that's the pi over 6 angle. So we're going to continue further. So in part F right here, right? Let's look at how about we want to calculate sine of the 30 degree, 60 degrees. Or you can also call that the sine value of the pi over 3 angle, right? And then we also, at the same time, want to calculate the cosine value of the 60 angle, or cosine value of the pi over 3 angle. So we just learned a new radians, the measurements of an angle. Okay. So in the picture, this is how I'm seeing it on the unit circle. Alright, the unit circle, radius 1, right? And of course, I'm not an artist, so don't expect me to draw like a very nice looking picture right here, but 60 degrees angle is about there. You guys saw it? 60 degrees rotations, right? Or you can also call that as a pi over 6, right? That you can also understand that as pi over 3. Pi over 3, right? But then from there, right, remember the terminal point is right here. There's x coordinates, which is this distance, that's x. Sounds just y coordinates for your terminal point, which is this right here. We're good to be on that right there. And the radius is 1. So pi over 3 or 60 is just how much opening up, right? But your radius is right here, and you're still looking at a right triangle, right? So in this case right here, it's a similar, very similar setup. So the experience you guys had in the earlier work right here, we can reuse it. I'm gonna extract out that triangle. This triangle, I'm gonna take it out of the circle. I'm gonna put it here. See what I mean? Okay. There's. I should have labeled that more correctly. There's a 60 degrees angle here, or we see that as the pi over 3, right? This is 90 degrees angle right there. So it should be the 30 degrees here, right?
Yeah.
So it's exactly another 30, 60, 90 triangle. It's just we are standing it up, right? We're making it standing up, straight up. Okay. See what I mean? So the radius is playing in the role of the hypotenuse in this picture right here. You guys with me? So which side here has to be the half? It's the x, right? It's this adjacent side right here in the x. So 1/2 is right here. So that means what? X equals 1/2. You guys follow me on that, okay? And so, what about this other side? You can always reuse you can always use the Pythagorean theorem. Pythagorean theorem says the unknown, right now we call it y, okay? The unknown like y squared, right? Plus the other like we know is a half, but half squared, right? Pythagorean theorem says y squared plus 1/2 all squared must equals 1 squared, the hypotenuse squared. That comes straight out from the Pythagorean theorem. See? Hypotenuse squared equals 1/2 all squared plus y squared, the unknown length, okay? The unknown longer side, okay? That right triangle. So in this case here, a little further, we're looking at y squared plus a 1/4, right? Equals 1. And so now what we can do from there, we're gonna subtract 1/4 from both sides, right? Right, 1/4 from both sides. That will leave me to the next step right here, right? I'll have y squared equals what? The 1 minus 1/4. That gives me 3/4. Good there. So calculating the value of y is positive or negative square root of 3 over 2. Technically it's a square root of a 3/4, but then we did the exact same math on the square root. Okay. Right. And then in this case right here, should we choose a positive or the negative answer for y? In the picture right here, the y values right there, should we choose a positive expression here or the negative one? The positive one, right? Because the y value, see it says above the x-axis. See our terminal point says above the x-axis, right? So now we've had all we got y equals a positive, so 3 over 2. Now, what's our conclusion? Sine of the 60 degrees angle, right? Or you can also say that it's sine of the pi over 3 angle, right? What's the answer for those two? Same answer. It's the same, it's just different way of writing the angle. Now, what about cosine of the 60 degrees angle? Or you can also say that it's the cosine of the pi over 3 angle. That's it. Good. That's how it's done, right? And so we found another one. And then once you guys getting a little bit of a better hang on that, then things will go a lot faster. But let's fill it into our table with it. So, just like that, right? See, our pi over 3 angle is right there. That's the angle of the pi over 3. I don't even bother writing the degrees anymore, because everybody knows degrees, right? The x value, if you drop the vertical distance right here, that's y, but the x value is here. Right? The y value is there. So that's why right here we write it right. There's 1/2 for x, right? You guys read it out for me earlier, didn't you? And this is a positive square, 3 over 2 for the y value. You all saying up? Okay? Alright, so now I don't think there's any more need to leave this particular picture right here on the screen in front of you, because we can use right here. We can start moving on to a lot further over here. All right, you guys ready? So think about, and I mean, as far as example one, we can keep the point of my example one I'm using is we're going to keep going around the circle and track down the sine and the cosine value on each of these other angles again. See what I mean? Okay. So let me put a pencil pin right here. What angle is this?
3 pi over 4.
3 pi over 4, right? And here, so the angle is 3 pi over 4. Are we good with that? Okay? Okay. Now with the angle being 3 pi over 4. So what's the x value and what's the y value? See, allow me to explain it this way right here. You see how the picture is almost identically the same with this picture right here that we have? See the picture right there, right? It's almost identically the same. It's only that the x value is going to get flipped to the negative side, right? You guys see that right in the picture right there? That's why now I have a reason to say this. For that one, x coordinates, right? X coordinates is just negative what? Negative square root 2 over 2. See how I'm seeing that right there? Because it's the exact triangle that we have already done. And then the y value is still pointing up in the same way, right? The y value is still pointing up in the same way. So now I have a reason to say that, hey, sine, right? The sine value of this angle is a square root of 2 over 2, or the y value for our coordinates, for our terminal point. See how I'm explaining it right here? All right, let's make another call right here. What angle is this? Right at my pencil tip, right at my pen tip right here.
2 pi over
2 pi over 3. I agree. Right? 2 pi over 3. That's the angle, right? Or it's 120 degrees angle. So that's the angle. But then when we're right at that angle, the terminal point is here. So let's look at the coordinates. X coordinates and y coordinates. See, what's the x coordinates? See, when you, from that point, if you drop out straight down right here, right? The x coordinates is right about here, which is exactly the same as the x coordinates for the pi over 3, but opposite sign, right? Because it's the exact same kind of triangle that we're looking at. You guys with me on that still? So it looks to me like we got cosine. I'm saying it out. I'm saying it out loud, right? Cosine of a 2 pi over 3 is a negative 1/2, or the x coordinates for that terminal point. Okay? So start getting used to it. That instead of calling that the x value, I call it as a cosine of the angle. Okay? And then sine of the angle is a vertical coordinate, right? Sine of 2 pi over 3 is a, how much length is that?
Positive 3 clear.
There you go. Now you click it, right? Positive square root 3 over 2. See how we manipulate with that right from things we already had, right? And then I'm going to continue making this call right here. So what about this point right here? What angle is that?
5 over 6.
Yep, 5 over 6, right? That's the angle. Okay. So it's a 150 degrees angle, right? But we want to get used to calling that the gradient. Okay. So now, can anyone volunteer for me? What's the x coordinates for that, or the cosine of that? X coordinates. Right here is the x coordinates. Right there. Right. X coordinates. That distance. What do you read? What do you say? What's that?
The cosine of negative square root of 3 over 2.
Yep, negative square root 3 over 2. Right. That is the cosine of that angle. Yeah. See what I mean? So, right from that, what's the sine value here?
1/2.
1/2. Yep. All right. So now, what angle is this?
7 pi over 6.
7 pi over 6. Right. All right. So, what's the cosine value for that angle? Or the same as the x value of the terminal point, right? So cosine value?
Cosine of negative square root of 3 over 2.
You guys all agree?
Or negative.
And then what's the sine value?
Negative 1.
Negative 1/2, right? Right. Good. What angle is this?
5 pi over 4.
5 pi over 4. Yes, 5 pi over 4. Right? So, once again, cosine value.
Negative square root of 2 over 2.
Right.
And then
Go ahead.
negative square root of 2 over 2.
2. 2. Good. Okay. What angle is this? Like the next one.
4 pi over 3.
4 pi 3. Okay, I agree. Okay. Cosine value and sine value. Cosine first.
Negative 1/2.
Negative 1/2. I agree. Okay.
And then negative square root of 3 over 2.
Negative square root 3 over 2. I agree also. Okay. You guys all agree, right? Double check against yourself. Along yourself. What angle is that? 5 over 3, right? Very good. So, cosine and sine.
1/2.
1/2 for cosine. I agree. And what about the sine value?
Negative square root of 3 over 2.
Negative 3 over 2. That's the sine value. That's the cosine value, right? What about this angle?
7 pi over 4.
7 pi 4.
No,
Awesome.
so sine of
Yeah,
square root of 2 over 2.
yeah. Root 2 over 2. What about the sine value?
Negative square root of 2 over 2.
2. 2. That last one before the 2 pi. Which one is this? What angle is this?
11 pi over 6.
11 pi 6. Thank you. And then go ahead, read for me the cosine and the sine value again.
It's square root 3 over 2.
Root 3 over 2, right?
Negative 1/2.
And negative 1/2. I agree completely. And this is what you guys see right there. You open your textbook, it has this unit circle with all of the sine and sine and cosine value. It's just a little bit intuitive that a lot of times we say the sine value first, right? But it's as a pair of values right here, it's the next one, right? It's the second one on the pair of the coordinates. Are you guys agree on that? Okay. But see, keep reviewing this. I mean, keep using that the filled-in table right there. So I'm gonna bring in example 2 over here, but example 2 we only have to do a few problems right here. Once again, we want to find sine, right? Theta and cosine. Theta for each given theta. I'm going to just, for each problem, I'm only going to do just a few of this so that you guys get real comfortable with that. Right? But how about part A right here? Let's say when theta equals negative pi over 4, for example. Meaning, the question is asking you to find sine of negative pi over 4, right? And then cosine of negative pi over 4. So, the whole example 1 that we developed earlier, we were getting ourselves comfortable with knowing what the sine and the cosine value is. Now we're going to have to be a little more flexible than that, right? So here we deal with negative angle. You know what I mean? Okay? But it's not so bad. You now have your unit circle there, right? Here's your unit circle. Okay? We're always going to start at that spot right here, on the positive x-axis, standard position. That's how we call it, right? But how do we go negative pi over 4 this time? Yeah, the clockwise rotation, right? So negative pi over 4 is this angle right here. Same angle. So on your unit circle, you may have labeled that differently, right? But this time, because we're going in the negative direction right there, then it's that spot. So now it's your job, and that's why we learned about the co-terminal right there, right? So which angle on your unit circle is co-terminal with this angle right here? And it should be the same spot, the same sine and the same cosine value. Am I making sense? Okay, so take some time. Hopefully it doesn't have to be too long, but right there, what's your pair of coordinates? Negative pi over 4 should be coterminal with what angle? It's so pi over 4. I mean, pi over 4 is 45 degrees away, right? So negative. Right?
7 pi over 4.
There you go. So it's coterminal with the 7 pi over 4. 7 that, right? So that means that, but now we're looking for sine and cosine, right? So we use a coterminal idea just to help us locate the angle, but in the end, ultimately, I just want sine and cosine, the y and the x value. See what I mean? Okay, so since you already gave me some answer, why don't you finish to the rest? Okay. What's the x and y pair of values here? That you can find right from your unit circle.
So square root of 2.
Mm-hmm. That's for x, right?
Yeah.
And what's the other one?
And negative square root over 2.
That's right. And so now you can say that, hey, sine of a minus pi over 4 angle, right, is a negative square root 2 over 2. That's your answer. You guys see what I mean? And that's how we calculate the sine or the cosine value of a negative angle. And then this is positive square root 2 over 2. Or getting a little tired, so you can't write too well. Positive square root 2 over 2. That's how we do it. Okay? So when it gets to either negative angle or some other kind of crazy big angle, we got to use the idea of coterminal angles to get that. See what I mean? Okay. So in that way, I keep using that term like that. See, I mentioned for you guys the idea about coterminal just once, and then you probably worry a little bit that we didn't go too far in depth into that, but because that idea lives all over. So in a lot of other the examples, we keep having those. So what about in part B? We're looking at the angle theta as being what could be a good one. 13 pi over 6 for you. Okay? 13 pi over 6. Or you can also see this as a 390 degrees. See what I mean? Okay. So you want to calculate sine of 13 pi over 6 and cosine of 13 pi over 6. So the reading says it's a positive angle, right? You can see that in radians 13 pi over 6, or really it's 390, but as a positive angle, starting from the standard position, it goes clockwise with one complete cycle, right? Because one complete rotation is a 360. And how much further we go? Another additional 30 degrees, right? So that means what? I just said it. So 390, right, is this coterminal with what? The same as the 30 degrees angle. You guys know it? Right? Or the same as, so this is the 13 pi over 6, and this is the same as the pi over 6. Yeah, those are coterminal. See what I mean? So it's coterminal with that. So now you can just go ahead and read for me the x and y coordinates here, because once you know which angle on the unit circle is coterminal with, right, then you can go ahead and find that. Right? What do you say? Like I said, if you're still feeling that you're shaky, don't be shy, right? If you're shaky with the coterminal, keep bringing in the idea. That's how you learn.
Square root 3 over 2 and 1 half.
Right, square root 3 over 2, yes, for the x, right? So 3 over 2 and 1 half. Yeah, I agree. So that means the y value is going to become the sine, right? Sine is 1 half, right? And the cosine for that is square root 3, 2. All good? That's how it's done.